Hello, Assalamu alaikum students. I'm your teacher Amna Manzoor and today we are going to have a review of the chapter. We have studied this complete chapter, that is Organic Chemistry 1, chapter number 15 of your book. The chapter have been completed and now we are going to have a little bit review of the whole chapter today. There is a worksheet being shown on the screen. You can see that if anybody having problem in the worksheet or is not visible, just tell me. ओके नाउ बेटा हम लोग जो है ऑर्गेनिक केमिस्ट्री का जो टॉपिक पढ़ रहे थे दैट चैप्टर लेट्स जस्ट स्टार्ट फ्रॉम द वेरी बिगिनिंग आई थिंक कॉल डिस्कनेक्ट हो गई है जी ऑर्गेनिक केमिस्ट्री हमने स्टार्ट किया था Organic chemistry is basically the branch of chemistry in which we were talking about or we were studying about the organic compounds, and the organic compounds are basically the hydrocarbons, right? Now, we studied what the catenation process is. Why do we have a very large and the vast quantity of hydrocarbons in the industry? Why do the carbon form bonds with other carbon atoms and what the process is? That was the catenation process. After that, we studied about the homologous series, and we studied almost 4 to 5 homologous series in this chapter. We studied alkenes in detail, but we studied the introduction of alkynes, alcohol and ether too. So we studied the homologous series, and after that we just studied a few important points, what the homologous series are, how do they perform functions, and what the functional group basically is. So we studied the functional group of alkenes, alkynes, alcohols, and ether. So after studying all these topics, we were given a worksheet in which the related questions were there. Now, we were talking about the prefixes, the suffixes, and then we studied alkenes. Okay, let's just have a review of each and every topic we studied. First of all, we studied the catenation. So beta, catenation is basically the property in which the carbon atom is forming bonds with other carbon atoms. That is a self-linkage property, and that is a very specific property which is formed in the carbon, and that is basically responsible for the vast variety of organic compounds. Okay, moving towards the next point, we studied homologous series, which are the specific kind of series, or you can say the family members, the families in which all the organic compounds have similar properties. In one homologous series, the compounds have same functional group. Now, moving towards the next topic we have, that is functional group. Functional groups are basically the functionalities which leads to the specific characters of the series. For example, I told you that functional group assigns the specific chemical properties, right? Okay, now we were giving the nomenclature to the compounds, and for that purpose we use prefixes and suffixes, and we studied that suffixes depends upon the functional group, but the prefixes, that is meth, eth, prop, all these remains the same depending upon the number of the carbons. Now, moving towards the alkane, we studied its formula, that is CnH2 and plus 2, and we studied its simple physical properties, the phenomena of isomerism, COWS abbreviation, some physical properties, some chemical reaction as in combustion, that was complete combustion and incomplete combustion. Also, we studied what are its advantages and what are disadvantages, what the process of chlorination is, which means the addition of chlorine to the alkanes, and we also studied why the alkanes are less reactive, or you can say the least reactive in the case of hydrocarbons of alkanes, alkenes, and alkynes. So okay, Now, the next thing is alkenes, and in alkenes, we studied the formula CnH2n. It has two numbers of hydrogen less because of the what are you? Okay, we studied alkenes in which we studied the formula CnH2n plus, CnH2n. There were two hydrogen less in the number because of the presence of double bond. It was basically the functional group of the alkenes. Now, the isomerism phenomena in alkenes, the physical properties of alkenes, COWS abbreviation for ethene. Why do we not have one carbon compound in alkenes? Its chemical properties, addition reactions, why they are more reactive than addition of halogens, addition of hydrogens, polymerization process, margarines and cracking of alkenes and alkanes, formation and the steam cracking, and after that we studied catalytic cracking. All these things have been studied. Now, fuels or the chemical feedstock is a minute topic. Two paragraph statement is there in which it has been explained that crude oil basically is a non-renewable source because it takes much and much longer time to generate it, but it is consumed immediately because it is basically flammable. So it is better for us to generate some kind of materials or some kind of stocks that can be used instead of crude oil, because crude oil took million of years to produce, but it is used very fastly in the modern society that it is just an imagination that it will be consumed uh, whole amount of it will be consumed by the end of the century almost. So for that process, it is mostly said we must have another source for the fuel or for the burning and the used in the transport processes, so that we can use it in some proper and more useful ways. Now, let's just move towards the worksheet that is being displayed on the board, on the screen. We have the first question, that is choose the best option. We have some of the multiple choice questions over there. The first one is which of the following compounds has a structural isomer? So this topic, or you can say this question, is about the isomerism phenomena. As you all know, we have the phenomena of isomerism in the case of hydrocarbons. We also know that isomerism is a phenomena that is found in all the homologous series but is not found in all the compounds. The reason is, for the isomerism to be operative, we must have sufficient number of carbon atoms that by changing their arrangement, by the chain number, the functional group, the compound's structural formula can be changed. So depending upon that knowledge, you have to draw these four isomers, and just to obtain the correct answer you have to choose the best one, which one will have the structural isomer and the other will not. Now, moving towards the next question, we have how many products may be formed by the chlorination of methane? We studied the phenomena of halogenation. So, halogenation was the phenomena basically in which we studied how the halogens mean the members of the group 7, how the halogens are added into the alkenes. We studied why the alkenes are inert and how they undergo the substitution reaction. So you have to form, or you have to focus on the substitution reaction of methane by the halogen chlorine, and after that you have to tell us what number of products will be obtained. You know, the this process basically leads to the formation of number of products because carbon have more than one hydrogen that can be replaced. So how many products can be there? You have to answer that. Now the next question is which of the following best describes which of the following best describes what happens during cracking process? Now you studied the cracking process. Now there are four options. Number one is short chain alkanes. Two short chain alkenes means small chain alkenes are going to be converted into small chain alkenes. Okay, the second is long chain alkanes to short chain alkenes. Okay, sorry, short chain alkanes and alkenes. The third is long alkenes into short alkanes and alkenes, and the fourth one is short chain alkenes to long chain alkanes. There are four options. You have to choose the best possible answer for the process of cracking. Clear? Now, which of the following compound is not a hydrocarbon? Now you have to tell which of these compound is not a hydrocarbon. We have four options. Okay, Ji. We have the first compound methane. The second one is CH3, CHOH, CH2, CH3. Now the third is CH3, CH2, double bond CH2, and the last one is CH2, CH2. Now you have to focus on what the characteristics or what the properties of hydrocarbon are, and what is the criteria on which we will decide either the compound is hydrocarbon or not. Depending upon that properties or characteristics, you will be deciding either the compound is hydrocarbon or not. Now moving towards the next section, we have question. You have to define or you have to identify the following terms. The first one is homologous series. You have to tell what is a homologous series, and remember one thing, you have to give at least one example with this definition. Now the second is structural isomerism, what the structural isomerism phenomena is, and also you have to give one example with it. Now what the functional groups are, and also you have to give one functional group example. Now the prefix BUT, you have to tell us what the prefix BUT actually means and for what number of carbon it is basically used in the case of hydrocarbons. Clear? Now the fifth one is polyunsaturated. So you have to tell what the term polyunsaturated means in the term of hydrocarbons, alkenes, alkanes, and alkynes, and either is there any hydrocarbon series in which this term does not operate. If not, then tell me why. Now the third one is draw the structure showing all the atoms and bonds of propane, and use the structure to explain why propane is both a hydrocarbon and an unsaturated. I think there is a problem in the question. Draw the structure showing all the atoms and bonds of propane. Use the structure to explain why propane is both a hydrocarbon and an unsaturated. Okay, it is not propane, it is propene. I think there is some typing mistake. So you have to tell why propene falls on both the categories, why it is also considered as hydrocarbon and as an unsaturated compound. Both these terms are valid for the compound propene. You have to tell the reasons for both. Now moving towards the question number 4, a student is provided with two beakers having two different kind of hydrocarbon solutions, right? One of the beaker contains a compound of alkene series and the other contains the compound of alkane series. Which chemical reaction or the chemical test will be used for the identification of these compounds? Give the general reaction for the test. Okay, now basically we have been asked for a test for the identification of the series. This is basically a question related to the bromine water test. So bromine water test is basically used for the identification of the presence of unsaturation. For example, if you have been provided with a number of solutions and you have to identify which one of these have unsaturation in them, so you can use basically bromine water. You just have simply to pour that bromine water and mix with the substance you have been provided in the beaker, in which bromine gives off its color and decolorizes itself. It means bromine have formed bond with the unsaturation. It means addition of bromine have been occurred over there. So at the end of that reaction, you will be able to say that the beaker which have decolorizes the color of bromine water is basically the beaker containing unsaturated, means alkenes or alkynes in it. So simply, whenever you have been asked about the identification of unsaturation, do remember the front person is asking you about the bromine water test. It means you have to identify what beaker, what substance, what compound you have been provided is having double or triple bond or not. Simply use bromine water, add it into the liquid. If it decolorizes, it has unsaturation, it may be an alkene or alkyne. If it does not colorize, it can be any compound, but it do not have any unsaturation. That test is basically also used in the laboratories. You will be performing it inshallah whenever you will be in the laboratory, right? Now, moving towards the next topic, we have vegetable oils can be used both to make margarines and as fuels such as in biodiesel. Explain how margarines can be manufactured by the unsaturated vegetable oils. Okay, ji. Now you have to tell how the margarines have been used, how the margarines can be manufactured from the unsaturated vegetable oils. We have been studying about the margarines that are basically studied in the topic of hydrogenation in the chapter. So you just have to give a brief explanation how you can use vegetable oils to produce these quantities or to produce these compounds, in which gas is basically used in the process. Next is crude oil is a raw material in which crude oil is a raw material which is possessed in an oil refinery. Two of the processes used in the fractional distillation and cracking. Now this statement is using a term called cracking. You have to define this. The secondly is how many types of crackings are there. You have to name these type of crackings. Number third is what is the purpose of fractional distillation in the case of crude oil. You all know that crude oil is not in the state, is not basically in the state that can be used so easily. So we have to perform the cracking phenomena, and after the cracking it is converted into it is converted into short chain alkanes and alkenes. So basically at the end we are having a full mixture of compounds that are produced as a end product of the crude oil. So that end product mixture is basically identified and then separated by the process of fractional distillation. You have to just make proper statements and pen down the answer of this question, that how are you going to use the fractional distillation process, right? Now the seventh question is give the conversion of butene into butane by the chemical reaction and what name is used for this chemical reaction. You have been using the chemical properties term for studying the chemical reactions in the case of alkenes and as well as in the case of alkynes. So in this reaction you are studying about you are talking about addition reaction. Butene has to be converted into butane. We just have to write down the chemical reaction and also tell us what the name of the reaction will be there. Eighth one is alkenes cannot undergo addition reactions with the group 7 or any other element, right? Alkenes cannot undergo addition reactions with group 7 or any other element. What kind of, there are so many typing mistakes. Alkenes cannot undergo addition reactions with group 7 or any other element. What kind of reactions are exhibited by the alkane series? It is a simple question that alkanes are not going to undergo any kind of addition reaction. So just tell us why do they do not have any kind of addition reactions, right? The next question is, write a balanced chemical equation for the complete combustion of ethene molecule. The next one is, describe how the boiling points of unbranched alkanes vary with the size of their molecules. So you have to just tell us about the unbranching of alkanes, how it is going to affect the boiling points. So it is a simple phenomena, beta. Whenever you are going to perform the process of cracking is going to produce a mixture of low chain or small chain alkanes and alkenes, and at the end you will be having a observable decrease in the boiling point, because whenever the chain length is decreased, automatically the boiling point is also decreased. So whenever we are talking about the cracking process, the end products of the cracking will have lower boiling points as compared to the parent compounds. The second part of the question is, what is the effect of cracking on the boiling point of the hydrocarbon? That is basically the answer lies in this thing. Hydrocarbons will have lower boiling points whenever they are low in the number of carbons. So the cracking is basically going to reduce the reduce the boiling points of the hydrocarbons. Now, 11th question or the last question of the worksheet is, give the reactivity order of the following series. Now, the reactivity order you have to determine for the series are alkanes, alkenes, and alkynes. You have to tell us which one of the following is the most reactive, which one is less than that, and which one is least reactive. So, for now, I'm telling you the answer that the least reactive is alkanes, and the mid one are alkynes, and the most reactive is alkenes. Now the answer is, some of the students may have doubts regarding this, that ma'am, we are having two pi bonds in the case of alkynes, so it means it is having two or the double amount of electronic cloud exposed into the environment, so it must be more reactive as compared to alkene. That is the basic misconcept that the students have been occurred with. But remember one thing, alkanes are least reactive because they have only sigma bond that lies on the bond axis. But in the case of alkynes, they have two pi bonds. One of the pi bond is emerged out of the air, is found in and above and below the bond axis, that is making it quite very reactive. But whenever the third bond, it means the second pi bond is formed, it wraps up around the pi bond, so making it quite inert. So it is no doubt more reactive than alkanes, but is less reactive than alkenes, because alkenes bond was only one and it was exposed to the environment and very much ready for the reaction. But alkynes have two pi bonds, so that doubling of the pi bond is not that much reactive as in the case of alkenes. So the most reactive ones are alkenes, the least one are alkanes, and in both of them mid of the line is alkynes. So this was the worksheet, but still some of the questions are here which I have not explained yet, and you have to answer them. Try to solve this worksheet by tomorrow, and on the Wednesday, inshallah, we will be starting the Organic Chemistry 2, that is chapter number 16 of your book. Try to solve and submit this worksheet before that. Thank you so much. Allah Hafiz.